We're live. Perfect. Hello, welcome everybody. Welcome to the third hackathon. The third workshop of this hackathon. We got two amazing ones with Tolly from Berries and then also from Elias of Programmable. And today we have another amazing one, a bit more technical, but I think will be very, very insightful for everyone basically joining. This is, as I've mentioned, the third workshop. There will be more coming this week, I think 3 in total. So also keep an eye on, and the idea is that we make these live streams also, not only useful for the builders that are trying to participate on the hackathon, but also for the users. And today we have sedaprotocol, which is one of the best infra providers for anyone that wants to, build a prediction market project and getting, access and setting transactions quick. So we have also Jasper, the CTO himself, who's going to walk us on, how to write a SEDA Oracle program itself. And a reminder that there will be time for questions at the end. So, feel free to join the stream, put some questions on the chat, and I'll write them down and keep a log on those, and we'll be able to ask them at the very end. And without further ado, let's just give the word to Jasper himself. And again, thank you for joining, and thank you, Seda, also for hosting this workshop. So yeah, Jasper, how are you doing?
Doing great. Thank you so much for having me, Omar. Yeah, like you mentioned, we are today giving a little bit of a technical deep dive and masterclass into accessing data using SEDA on BSC. And in the example I'm giving today, I will show you how to settle a prediction market, so decide an outcome based on API data. So that is sort of like the TLDR of the next 30 minutes. And then, whenever we're ready, I'll dive into that.
Yeah, let's go. So let's move to presentation mode. There we go.
Cool. My screen is sharing, right?
Yeah, absolutely.
Perfect.
Yeah.
All right. So right now on my screen, you see that I created a public repo on my personal GitHub that you can clone, and you'll be able to use and work along with me if you want to, or you can probably watch back the stream and go over the steps a few more times because it is quite technical. So if you clone this repo, which I've already gone ahead and done, let me open it up right now. You'll see a project with the following structure. You will have a env.example file that you can I've already gone ahead in the root. And then we have for the actual, so this is in the root, we have the logic for the Oracle. And then in the integrations, you have a bunch of EVM contracts that will actually allow you to consume the data and query the data. And so here's another env file that you can fill in. So this is like the example. So just copy that over and add the parameters according to the documentation in the README. But we'll do all of this except for filling out the env variables. So first things first, if you want to use SEDA on testnet, you can go to our Explorer. You can go to the faucet, connect your wallet. It's a Kepler wallet, and request funds. And this will give you 500 SEDA to work with, which will be more than enough for this demo. So if we go to the dashboard, what we will do first is go over the data feed. And so the data feed consists of 2 phases, an execution phase and a tally phase, which are combined just simply in this main. If you want to learn more about this, it's a little bit of an abstract concept. You can go to our docs and go to Understanding Data Requests on SEDA Core, where it will walk you through the entire flow of what actually happens under the hood. But for now, all you need to know is in the execution, we decide where the data should be queried from and how it should be transformed. And in the tally, we decide how the data should be aggregated if we have multiple operators fetch it. And so as you can see in this tally phase, we just take a median of all of the executions. And so if we go to the execution, you see that we expect some sort of CoinGecko ID as an input. We then fetch using a data proxy that's connected to the CoinGecko API, passing in the CoinGecko ID. And we check that this all goes according to plan and passes. Then we actually take the price as a float and we convert it to a unsigned integer of 128. You want 108, and we multiply it by 1 million to get 6 decimals worth of precision. And then we report that as a result. So as I said before, this will do an execution and report it as a value, like a price, and then that all gets tallied up in a tally phase, and you get sort of like one consumable outcome. I can demo this now. So in the env variable, you can copy these Explorer and RPC URLs, and then you have your mnemonic that you get from the Kepler wallet, and then you have the program ID, which we're going to generate right now. So we're going to do run install, and all of these steps are outlined here. So we have the installation is not there, but it should. So yeah, we run the install, then we do run build, which will compile this into a deployable Oracle program. Which is a WebAssembly binary, and then we will run deploy. Boom. So now we have an Oracle program ID. You can add this here to your actual env file, not in the example. And then if you go to script, you have this post.dr file. And here you can see that in the object we are passing into this query, we give the Binance coin, which is the CoinGecko ID of BNB, as an input. And so what this execution phase will do is that it will fetch the price of BNB and return that. Somebody's entering my room. Okay. And so if we want to query this, we do bun run post.dr. Hey, you need me? Okay. Okay. My co-founder Peter.
Building, just busy building.
Exactly. And so we're now posting the DR. And if we go and take this Oracle program ID and we go back to the Explorer, we can paste this, and it will show you that a new data request was issued around this time. And the result, which is big endian, which means that the price of BNB at the point of me querying this was about $945.5 because we multiplied it by 1 million. And so, yeah, now the price has landed on chain. It's been reported by our overlay network, and this is not useful on BNB yet. So that's the next step we're going to walk through. So if we go to integrations and then, so enter the integrations EVM hard hat example directory. And in there, we have the Oracle program ID again, so that's this, and your EVM private key. So it's a private key that holds some BNB. And then optionally, you can also add your Basepolia, or no, not Basepolia, your Etherscan API key. This is using V2 now. Cool. So once you've done that, you can again install here. So bun install. And if you want to read with me and do this on your own time, You can go to integrations, EVM hard hat, and follow the steps here. And so after installing, we can do run compile again, which compiles 2 smart contracts. We have a price feed. So this is a price feed that allows you to both query and read the BNB price in a similar way as we just posted the DR. You have this transmit function which pings the SEDA core API, which we have solvers watching, that actually does the request and then relays it back, after which you can call the latest answer function to read the final outcome. Then secondarily, we have a example of a prediction market I wrote really quickly. It does not have trading or anything. It just has sort of like the basic necessity, like it can be settled, and it checks whether the outcome is there and whether the answer time is like after expiry, or the Oracle price came after expiry, and then settles it based on whether the price provided by the Oracle is higher than a price set. So the prediction market would be, in this case, let's make it a set it to I don't know, go with $900, right? And it expires immediately. And so basically, if the price reported by the Oracle of BNB is above 900, then the settle market will settle the market as settled above strike price being true. Yeah, and so yeah, these two together are basically all you need, or like the price feed is actually all you need to build this logic into your prediction market. And I'll dive a little bit deeper into other possibilities later. But for now, we can do bun run bun x. We have the commands here. So we're now deploying the price feed and the market to BNB. Done. And we're also verifying the contract. So if we go to see, we have the my market contract here, which can read. All right. And we also have the price feed contract live, but we don't need to touch the Etherscan really. So what we can do now is we can transmit to the SEDA network. So we call the price feed using this contract that we just deployed on SEDA testnet. And so if we go here, not there yet. Waiting for a solver to pick it up. There we go. Come on. There we go. And so this means that the data request, the transmit function that we just issued on BNB has been notified by the SEDA network. And now the decentralized network is actually querying and executing the execution phase and the tally phase, which is done. So we can read the result, which is $943, which means that the market should be settled to true. And so what's happening now is on the SEDA side, like as soon as this market was finalized, we have a set of solvers that then reports the price back. And we can read that through the price feed. So where we just called it the price feed transmit function, we can now read the latest. And boom, we see that this price here has been reported on BNB at this timestamp. And so as this is done, we can now settle the market. So that's the settle function on the my market contract, which now should settle to true, which means that the buyers of yes shares in this market should be paid out, basically, right? So yeah, you can see it's settled above the strike price, because the strike price was $900. The actual price is $943. And the answer timestamp was before like after the settlement window of the market. And so if we go to the my market contract now, we are here. You can actually read that it's settled, has expired, when the answer came, and that it was settled above the strike price. So we've just built basically an entire end-to-end flow from not having any data on BNB to accessing the right data and just settling a market. And so what's really cool here is now that we have this, all we need to do to get new data to land on chain is change this to, for example, you could change it to PancakeSwap or any other BNB coin, and also access that data on BNB just by changing the inputs in. So you can do it here, but if you actually want to use it, you would do it in the price feed. You change this to, I don't know what the Pancake CoinGecko ID is, but yeah, that's basically it. And so in this example, we did using price feeds, but the possibilities of what sort of data you actually access are actually endless. So this happens to be a CoinGecko API endpoint, but this could also be a I don't know, sports betting or sports market or a sports API or a political API, any sort of API that has the outcome that you want to settle your market with, you can paste here. Change some of this logic in case it's a string value instead of a numeric value, and settle all your markets with sort of like this single infrastructure without having to talk to us or needing permission essentially to build this, right? So yeah, I think that is most of what I wanted to showcase today. Curious if there's a question. I know this probably went pretty fast and was quite complex, so if there's anything you guys want me to double click on, or you want to rewatch it, or you want to look at any further documentation can be found at docs.seda.xyz. We have, like I said, this directory that goes over sort of like this specific implementation. But if you want further examples, we also have the request starter kit, which all will be linked by the CDFI team, but this has other further examples. And we also have actually the example. So example Oracle programs on our GitHub, which hosts a ton of examples of possible data that you can consume on any EVM chain. So yeah, let's open up the floor.
Perfect, Jasper. No, thank you again. This has been very insightful, even for myself. You know, which I don't have a very code development or technical background on that end. So like knowing to understand how these sort of on-chain settlements work, and the background or the backend behind that. So that's great. I appreciate that. I think on questions, we've been a bit quiet, but I think you also touched a good point on documentation, because I was going to ask about that. Like, what's the best place to get on any guides, feedback? You also shown the example there, so I think that's also useful in terms of best point of contact. Everyone can, we got the Telegram group, but I guess also there's channels where they can reach you if they need like more specific customer support.
Yeah, if they go to seda.xyz and scroll to the bottom, there is a link to our Discord, which has a developer channel. So yeah, you can definitely ask all your questions in there. I'll be hanging around for most of the day, and I'm sure the CDFI team will also forward some questions if they pop up.
Perfect. Thank you, Jasper. Yeah, I think the other, the versatility also on the types of APIs that you can work, like you can build something for, I guess, prediction markets on Polymarket, or you could potentially, I don't know, I was wondering, for example, like Grok AI, can you connect not Grok, I mean like Grok API or something, and even make prediction markets on social media posts, I guess, and stuff like that.
Yeah, you can do literally anything,
Whatever.
which is a little bit of an annoying answer, but it's also true. So if it has an API, you can plug it into our network. If it is custom data that we don't have an API for yet, or it's a private API, I would urge the developers looking at this to look at the data provider section of our docs, operating a data proxy, which dives into how to make private data accessible through our network as well. So it's not just public endpoints, right? The CoinGecko API is actually a private endpoint that we host using a CoinGecko API key. And so it's a way of accessing private data without leaking API keys or leaking data.
Yeah. So I guess it's, as you mentioned, any API with information is available. You have to sort of, I guess, parameterize or build your code around it, how to, classify this as outcome, right? And an outcome with positives and negative bets or predictions for favors, odds.
Yep.
Okay.
Yep. And so, yeah, it's very easy. Like if you build this in a factory model, you can really quickly create like 1 minute prediction markets on the price of BNB that settle every minute automatically without talking to us or having to manually create these markets, right? So I think that's really the power. Like no manual settlements, no manual, sort of like intervention at all.
Programmable. Yeah. That's awesome. Yeah, that's really powerful. I think it's just just amazing how technology is going up, is progressing. Yeah, but no, amazing. Thank you, Jasper. Again, I think just double check. Yeah, there's no more questions on the chat side. So again, like the workshops also will be recorded for available for everyone. So if you even join late and see the link, like again, you can reach out to us. You can Jasper also has shown the ways that you can access documentation, support from SEDA protocol. So that's been awesome. And again, thank you everyone that's joined. Thank you, Jasper, again. And for the rest of the guys, I'll see you into the next workshop. So yeah, thank you again. Take care.
Don't hesitate. Thank you.
Bye bye. ¿Ah?